Okay, number 19. Cube root of 8x minus 24. Okay, we now have different from what we've been doing. If you look at all the other problems, we just had one number, or numbers being multiplied, numbers lined up being multiplied. Now we have numbers being added. So you got to kind of approach these. Let me focus that. You need to kind of approach these a little differently. Hopefully you remember factoring from a few sections back in this book. Let's first look at it and think, what can we take out from both of these factors that they both have in common? They don't both have an a. We can't take the a out. They do both have 8 in common. 8 can go into 24. So let's first, and I say take out, I don't mean take from under the radical yet. I just mean make a parentheses under here and take out what can come out. 8 will come out. So 8 can come out. What will you need in here to make back your original 8x minus 24? You will need, let's see, 8 times what makes 8x? 8 times x. 8 times what makes negative 24? 8 times negative 3. So that's how you'll write it. It's the same number, you just broke it up. Now we'll look at it as to how we can bring something out from under the radical and make it a little simpler. Cube root of 8 times x minus 3. Hopefully you see a perfect cube right there. That's just cube root of 2 cubed times x minus 3. And that's just, take the 2 out. 2 times the cubed root of x minus 3. You don't have to worry about the parentheses anymore. It's just there so that we know that 8's being multiplied to the x and the negative 3. So our answer is 2 times the cube root of x minus 3. All right, let's do number 21. Same thing. Focus right here. Okay. 21 is 27c to the 6th minus 27c cubed, all to the 1/3. Remember, we need to find a way to write this into a radical. 1/3. The 3 tells us the index for your radical. So let's write out that radical. It is a cubed root, thankfully, because those 27s are going to work perfectly in a cubed root situation. Okay, let's factor out what we can while we're still under the radical. They both have a 27 in common, and they both have a c cubed in common. This just has c cubed 2 times. So let's take out 27c cubed out of both. Write your 27c cubed in front, and then write your parentheses and think, what do I need in order to get back to what they were? 27c cubed times what makes 27c to the 6th? Well, times 1c cubed. If you did the multiplication, it'd be 27 times 1 is 27. C cubed times c cubed is c6. Alright, so you don't have to write the 1 there. I just wrote that in case you didn't understand why, but I'll write c cubed. So that'll get it back to 27c to the 6th. And on this side, what'll get 27c cubed to make this? Well, just a -1. That way you get your negative back when you multiply it out. So now it's separated the way we want it. We separated it because we want to be able to take something out from under this radical. And this is a perfect cubed all the way around. That cubed root of that is 3. Cubed root of this is just c. So let's write that out. 3c comes out. And everything else will stay under. And don't forget your index. Cubed root of c cubed minus 1. That is your answer. 3c times the cubed root of c3 minus 1. Hopefully that's readable for you. Okay. Number 23. Okay. Hopefully we can squeeze that in there. 23. Okay. It is the square root of 5x squared minus 10xy plus 5y squared. This is really a factorable series of numbers. I'm trying to think if that was called what the correct term for that is, but perfect, some kind of square trinomial is under the factoring section. I think that was in the, okay, here we go. 2.3 perfect square trinomial. That's what it's called. Three terms separated by pluses or minuses. That's how you know. All right, 3 terms, perfect square trinomial. You can look back at section 2.3 if you want to review how to do these. Hopefully this will come back. The middle number is twice the root of this and the root of this. So the root of the root of 5x squared is x times square root of 5. The root of 5y squared is y square root of 5. 5 can't come out. And then when you multiply these together, it makes, well, square root of 5 times square root of 5 makes 5. Well, that's not in focus. Square root of 5 times square root of 5 makes 5, and x times y makes xy. And then, so the root of this side times 2. If that works out to make 10xy, to make what's in the middle here, then you do know that that it is a perfect square, and it will work out when you factor it into that perfect square. Here's how you factor a perfect square. You take the root of this, square root of 5 times just an x, and square root of 5 times just an x. And then okay, I just had to think about that for a second and it came back to me. Perfect square is when both factors are the same. We're going to work all this out to prove it to ourselves. I know factoring was a little while back. I'm going to write the x first because it's sort of the whole number. 5's under the root. X times square root of 5 minus y times square root of 5. I'm taking the root of both of the ends. And I'm making it a minus because I see that my 10 is a minus. I know that's going to work out. Times x times square root of 5, same thing, minus y times square root of 5. Do your math real quick. You do the distributive law of multiplication, whatever they call it. This one to this one makes x squared times square root of 5, and square root of 5 is just 5. So 5x squared, that's what that one makes. This one will be minus x, y, square root of 5 times square root of 5 is just 5. So xy 5, or I'm going to write it 5xy. Alright, let's do this one. Negative times positive. It will be a negative 5xy again. And this one times the end times the tip is a positive 5y squared, y squared. So does it come out to be the original? I was just testing this to make sure our factoring was on track. And yes, 5x squared, that matches. Negative 10xy, yeah, these will combine to be a negative 10xy. You can add them because they have like variables attached to them. Plus 5y squared plus 5y, yeah. So our factoring was right. That was the main thing. It was all about, let's get that factored. And I'm run out of room. So bear with me. You see the old work here. You can pause the video if you want to study it. All that we've done is factor and put a... Now that I checked my factoring, I'm going to kind of go on working the problem. But take your numbers right here, the ones you factored, put them under a root. Now, commit that to memory. And let's continue. We have the root of x square root of 5 minus y. I'm sorry, minus y square root of 5 times x square root of 5 minus y square root of 5. Why did I go to all that trouble? You may have forgotten, but we're trying to get something out of this radical. We have something times the same thing. That's just written easily as x square root of 5 minus y square root of 5 squared. Oh wow, we've got something squared under a square root. That means you just take out the base. So really it'll come out and be a x times the square root of 5 minus y times the square root of 5. And it's a whole now. It's not under a radical. It's not a squared under a radical. It's a plain old base under nothing. And that is the answer to number 23. And Abeka would like you... Oh, okay. Abeka saw one more way to factor out, and I didn't notice that. But your square roots of 5, since they both have one of those, you can take the square root of 5 and put it on the outside. And then just write x. And then just write x minus y. And they would actually have you writing your radical at the end. They seem to want the radicals scooted over. That's how they would have it written. They would have taken the x and the y, spaced them out to here, and put the 5 there. That way you could redo your work. X times square root of 5 minus y times square root of 5. It would all come back out. A lot simpler way to write it than they had before. Okay, 25. 5a to the 4th plus 10a cubed x, 10a cubed x, plus 5a squared x squared, all to the 1/2. 1/2 just means they're under a square root sign, so let's do that. Just take one step at a time. 5a squared plus 10a cubed x plus 5a squared x squared. This is feeling like another perfect square trinomial. Let's see if this one I can do a lot faster than I put you through the last time. Okay, to make a perfect square, you need the root of this and the root of this. Let's make our parentheses. I'm making this a little bigger so you can read it. The camera's kind of far away. Alright, I'm going to write a 5a, because I know I should write an a square root of 5 if I want to make a squared. 5 like that. And for my last term, I know a square root of 5 here. So I know they're going to be multiplied to each other in the ends. That's why I'm putting a square root of 5, because I know at some point my a is going to be multiplied to this one, to another a square root of 5. And I know this one will be multiplied to itself right here. So the square root of that is ax square root of 5. And I'm writing all pluses because my middle term was a plus as well. So I know that there were no negatives to have to deal with. Ax square root of 5. I hope factoring is coming back to you as we do this. So I've written it out the way I think it will factor. I think it's a perfect square. I think it's going to work out. Check your work for sure if you're doing this and you're at all uncertain. So I'm going to check it. This term times this term, a squared 5, or I'll write it the right way, 5a squared. This times this, the a will make an a squared. The x will just be an x. The square root of 5 times square root of 5 is just 5. So 5a squared x plus, now we do inside terms, a squared x, they will add, and the square root of 5 is square root of 5 is just 5. And then the end terms, plus square root of 5 times square root of 5 is 5. Ax times ax is a squared x squared. Now, see, it does line up. When you're all done, you can see 5a squared, yes. 5 plus 5, 10ax squared, a squared x. And then this one, 5a squared x squared. So yes, we have factored correctly. This was just to check our work, and we did that right. So let's continue with the problem. We've got something times the exact same something. We can write it as that squared. So under my root, I'm going to write a times the square root of 5 plus ax times the square root of 5 squared. Now that's easy. I just take it out of the root and it becomes just the base. So my answer is a times the square root of 5 plus ax times the square root of 5. After we just did this last problem, I hope you can see a way to factor out one last little step. What do they both have in common? They actually both have an a and a square root of 5. So let's take that out. A square root of 5 on the outside. What will it take to make the old number? 1 to make this one. Plus, well, basically it just needs an x. Because ax square root of 5, we've already got everything else. If you multiply this plus this, you get it back again. That's your answer. A times the square root of 5 times 1 plus x.